Now we'll talk about finding the sum of a geometric sequence. Just like in arithmetic sequences, we actually have a formula to help us find the sum. And the sum of the first n terms of a geometric sequence is a sub 1. Ooh, sorry, that looks messy to me. A sub 1 times 1 minus r to the n divided by 1 minus r. Again, this is not a formula that you need to memorize. You can use it in your homework. You'll be given it on quizzes and such. So don't waste time memorizing those kind of things, but just make sure you understand what it is you're finding and how to find it. Okay, so we know all the things in this formula, I think, but let's just write down a few. So S sub n is the sum of the first n terms in a geometric sequence. And then, of course, a sub 1 is the first term. R is that common ratio. And n is the number of terms. So we're going to take an example, 3, 6, 12, 12,288. Okay, so this is a geometric sequence. We have the first three terms and we have the last term, the nth term, right? So in other words, this is a sub 1, this is a sub 2, this is a sub 3, this is a sub n because they didn't actually tell us how many terms that we had. So we are going to have to find out what n is in this problem. So we are going to write this in summation notation, and then we're going to actually find the sum. Okay, so let's write that down. Write in summation notation. And find the sum. Okay, so let's start by trying to write it in summation notation and see what we know and what we still have to find. So first of all, we know that we're going to use the sigma. And we know that we use k as the index, and we're going to start from 1, but then we have to go up to n. So we don't know what that n is up there. Now, what we need next is the formula for this sequence. So we know the formula starts with a sub 1, so 3 times. Now we need the common ratio. So let's see, we already know a sub 1 is 3. Do we know the common ratio? Sure we do, right? It's pretty easy to see that it would be 2, because 3 times 2 is 6, times 2 again is 12. Okay, so the common ratio must be 2, so that is times 2 to the k minus 1. Remember that we're using k as the index there, and n is going to be a number that we plug in. Okay, so we actually know everything that we need to know for this summation notation except for the n. If we go to the sum formula, S sub n, we still need to know that n. And then we know in this sum formula, we know a sub 1 is 3. And then that's going to be 1 minus r is 2 to the nth power over 1 minus 2. So what we really need to find is n. What number term is this, right? And then we'll be easily able to finish the problem. So to find out which term this is, one option, although it could be tedious, is like to multiply by 2, get 24, multiply by 2, and count how many times we multiply by 2 until we get to this term, right? Personally, I wouldn't do it that way because I'd probably be off by one number just by like miscounting or something. I don't know. If it was 12, I would think it was 13. If it was 20, I'd probably get 21 or something, So I don't like to do it that way, but it is an option. I think what would be better is if we set up the formula a sub n is equal to a sub 1 times r to the n minus 1th power, right? And then let's do that for this term for 12 for a sub n. So 12,288 is equal to 3 is a sub 1 times 2 to the n minus 1th power, right? So we really know everything in this equation except n, and we've already learned a way to solve for variables in the exponents. Yay, logs, right? I knew you were wishing logs came back, right? And here they are. So don't panic, it's easy. So we're going to divide both sides by 3 to get this extra number out of there. I did that and got 4,096 equals 2 to the n minus 1 power. Now, because the variable's in the exponent, we change to log form. So that would be log base 2. And remember, you switch, so the base stays the same, it's still 2. You switch the location of the other two parts. So this is of 4,096 is equal to n minus 1. Okay, so all I did was take this exponential, convert it to log form. There are other ways to solve this. You could take the log of both sides. That was another method we did back in the log chapter. If you prefer that, that's totally fine too. Okay, so now log of base 2 of 4,096, type that in your calculator, get that number, and then add 1 to it. So n is equal to, this whole thing I got was, what did I get? I got 12, right? So that's 12 and then plus 1, so n is 13. Okay, so now that n is 13, we actually know everything else. Let's go ahead and fix our summation notation. We know we want to stop at the 13th term. So this is the summation notation of the sum. And then the actual sum, let's erase the n here and here. We're finding the 13th, the sum of the first 13 terms, okay? So the formula is 3 times 1 minus 2 to the 13th over 1 minus 2. You can actually leave it that way, or 1 minus 2 is negative 1. So this would be negative 3 times 1 minus 2 to the 13th. Okay, sometimes these numbers are huge and you really don't want to go any farther. In this case, because it was just 2 to the 13th, I did calculate it. I multiplied it by the negative 3 and I got 24,573. Okay, so it wasn't too bad of a number, so I did type it in. All right.